So what is tolerance in this unit? So what have we done already? We've done accuracy, precision, uncertainty. Accuracy was all talk, concepts. There's zero math related to accuracy. For accuracy, we needed a standard unit and an appropriate scale. We also need the user to know what they're doing when they're using the measuring tool. And we need it to not be damaged, right? So 4 things for you to be accurate. Maybe I haven't talked about this enough, but accuracy, you need to be accurate in any industry, because if you aren't, you're gonna mess things up, right? If Coke decided to not be accurate with the amount of sugar they put in their cans, it wouldn't taste good. It would be too sweet, not too sweet, you name it, right? If you aren't accurate when you're a doctor or a nurse and you're supposed to administer medicine, if you're not accurate, you can cause either serious damage or you can put too little in there and it won't do anything, right? It won't really help you. So you got to be accurate, right? So sometimes we ask those questions as well. Just common sense there. You just use common sense, right? I tend to focus a bit more on the math part, but I will talk about that from time to time. All right. In manufacturing, the dimensions of a product may vary. Okay, this could be due to various factors such as operator error, faulty equipment, limitations to the measuring device, the temperature of the environment, and it goes on and on. Companies or businesses would lose a lot of money if they would only accept parts that match the target value. That is why most, if not all industries, allow for some variation. Okay? That way that part can still be used for its intended purpose. This is very important here. So we allow for variation so that we don't have to discard it, but we can still use it for its intended purpose. So there's some leeway there. You have some play to be off by a bit. And so this is a different color here. Tolerance is the range of acceptable measurements. It's also the measurement variation allowed so that an item is still acceptable for its intended purpose. So here are some practical applications of this concept. Let's say a company assembles doors for houses. I'm going to highlight this yet even a different color. When you are supposed to justify or explain using tolerance, you want to talk about it being either too small. Like what happens if it's too small? If the door is too small, there will be a large gap. Right? If the door is smaller than the frame, there'll be a large gap everywhere, so air can escape, mice can come in. You have issues, right? This will allow warm air to escape and cold air to enter the home. At the same token, if it's too large, if it's too big, it will not fit inside the frame. Okay? You just won't be able to even lock your door. So you can say, hey, you can't lock your door, it won't close, you name it. And I'll talk about this a bit more later. I'll give you some very practical applications of that. The tolerance would have to be in between the two scenarios above. Okay? And we have to differentiate between the uncertainty and the tolerance, because we've been talking about uncertainty and we're going to separate them. Okay? Uncertainty is determined by the measuring device. We call that the margin of error. So uncertainty is directly associated to your measuring device. That's why we have some uncertainty. And I looked up, I want you to add something here. I will just say assumes an error in the measuring process. That's why we say, hey, when we say 355 milliliters in that Coke can, in that can of pop, we can probably be off when we're measuring that. We can be off. So we're assuming that we're off. That's why, right? 350 mLs would always be tacked on with some sort of number. Sorry, whatever. We'll just go 0.5 mLs like that. Okay, so we're assuming that we're off. That's why we're going to say we're not quite certain. We could be over or under that number. Tolerance, on the other hand, it's determined by the industry, right? It would be like the range of acceptable values. So tolerance is the industry saying, listen, there's going to be a bunch of issues. There's going to be a bunch of things happening along the way. So we're going to automatically allow some leeway here. We're going to allow for a low and a high, okay? This is caused by human error, equipment malfunction, limitations to the device, and so forth. So tolerance is that difference. There's a min and there's a max that the industry allows. Okay? So they tolerate something. So let me tell you this. Tolerance can be very different than your uncertainty. Tolerance can be very different. Like the industry can say, no, we allow even less or more than what the uncertainty is. All right, let's keep going. And I'll come back to this because I know you're going to need to hear this again. Okay? I know you're going to need to hear this again. So don't panic too much, but I want you to focus on this page right now. Okay? Stating tolerance. I want to add something to this. Stating tolerance of a measurement. Let's put that down. To avoid confusion. Stating the tolerance of a measurement. Okay? In order to state the tolerance of a measurement, you need to know four things. The maximum, the minimum, right? The largest value, the smallest value acceptable. The nominal, what's nominal? That's our target. That's ideally what we're after. And the tolerance, which is the range or variation allowed. That is the new part today. Okay. So on your study sheet, I want you to have a tolerance section. Tolerance, like there's precision, uncertainty, all of that stuff. I want you to have a tolerance section. Okay? All right, so let's talk about this. I want you to think of the minimum is like the lowest acceptable, max is the highest acceptable. It could be length, it could be volume, you name it. Anything above this would be discarded. And anything that measures less than the minimum is also discarded. So I used to work at Kitchen Craft. They make kitchen cabinets. And so if we measured something and it was either above a certain measure or below, we would just scrap it, right? And so that's what anything above here is kind of scrap, right? We don't allow that. This is acceptable, okay? And so here you can see that the tolerance is the range of acceptable values. So if you were to take the max here and subtract the min from it, if you were to subtract these two values, you essentially get your tolerance. Like that's what's acceptable. So more on that later on. Let's see if this makes sense to you. If the tolerance is like the difference, this gap here. So this gap could be big, it could be small, it depends on the actual numbers. But I hope these formulas here make sense to you. To get the max here, you would have to take the minimum, add the tolerance, add this gap to it to get to your max. And vice versa. If we go to the min here, if you wanted to know the min, you would start with the maximum value subtract the tolerance from it to get to the min. So if these formulas, if these two mess you up right here, don't worry about them. I think this is the most important one right here. Right? Tolerance is max minus min. So here's where I need you to pay attention, because these need to find their way onto your study sheet. I'm going to add a lot of highlighting here. These are the 4 ways. These are the tolerance can be expressed in 4 ways. If given one, though, you can rewrite them into the other 3 forms. That is also important to remember. You can rewrite them if you needed to. So watch this. The first format you will recognize by the plus or minus half. If you see plus or minus half, you know it's in this format. Okay, there's no other like it. Okay, so then if you see the half, then you're like, okay, it's this one. So that means that the 250 represents the nominal, and whatever's inside the brackets is actually the tolerance. Okay, so you can actually know what those numbers represent. So let me just say something here. If this is the nominal, then that's what you would fill in here. I want you to every single time do this inventory right here, every single time. If you're able to fill in these 4, you can rewrite this format into any of the other 3 you'd like. But you have to do this inventory every single time. So this is a nominal, we got it, we got that number. We know that this 10 is the tolerance, so you already have it. Fill that in. And so how would you get the max and the min from this? And this is how you do it. You actually follow exactly what it says here. What's half of 10, by the way? I think you would all know it's 5, right? So to get the max, we would go 250 plus 5, right? We would add 5 to it. So the maximum acceptable in this case is 255 mLs. Make sure you copy this down. And the min is, guess what? You're just going to follow it. This thing will tell you what the max and the min is. You go minus 5, so that's 245 mLs. So this format of a measurement given its tolerance tells you all 4 things here. It tells you the maximum acceptable, the lowest amount acceptable, what the tolerance is. Does it make sense that it's 10? Subtract these 2. If you subtracted these 2, what would you get? Max minus min, you get 10, right? So it's jiving. And the nominal, I got it straight from here. Okay? Next, this one right here. You will look at this on, like the question or the exam or test will give you something like this. You will go to your study sheet and you'll have all 4 of these on your study sheet. And you'll be like, well, which one is this? It has to be one of these 2, and then you just look minus 0 plus 2. So the minus 0 is what gives this one away. Okay, so we are in this format. And based on this, the 5 we recognize is our min. So you go over here and you write down the 5 degrees Celsius. The tolerance is that top number. Watch. It's 2. Okay, got it? 2 degrees Celsius. The max, how would you find the max? If you looked at this, what would you say is the max? 5 plus 2, yeah. That's 7. So 7 is the max, 5 is the min, 2 is the tolerance. How did you get the tolerance, Mr. Dirksen? I got it from here because that's tolerance, but how else could I have gotten it? Remember max minus min? right? That should always jive. What's the nominal? That's the tricky part here. I will tell you that it is 5. It's that big number every single time. This is what we're after. This is the target. Okay. Ideally, we would want it to be 5 Celsius. It's also the lowest, but we also want that to be our nominal. Watch this. If you had gone 5 Celsius minus 0, you get your min, correct? So there's various ways of verifying this. Let's keep going. Next, you see one like this, and you're like, which one is it on my study sheet? And you will look at plus 0, okay, minus tolerance, so it's this one. So you've used this to help you out. I would argue that you don't need this, to be honest. Watch this. 45 plus 0 is 45, right? That is the max. This thing is telling me that. 45 minus 1 is what? 44, correct? How could I get my tolerance based on these two? Remember, it's max minus min, which is 45 minus 44, which is 1 millimeter, which is also confirmed here. And what's my nominal here? Any guesses? If I gave you this, what would you put as your nominal? What's the pattern up here? I grabbed this as my nominal, correct? So this is also my nominal. And I will tell you in a bit, I will highlight this part, and I will tell you that the big number up front, if there's a big number at the front of the whole thing, it's always your nominal. Okay. I'm almost done, guys. I'm almost done. I just want to finish this. The only homework will be to transfer this to your study sheet. Yeah. What about this one, max min? If you have two numbers like this, you cannot miss it, right? It just looks exactly like this. It's just two numbers stacked. What do you do there? Well, guess what? This is the max. This is your min. How do you get your tolerance again? Max minus min. That is 3, right? What's the nominal here? Just pick one, Mr. Dirksen, because I don't know. You have to find the average of the two. And that's where this one is a pain. Okay? So here's nominal is max plus min divided by 2. You need to know that this is what it's assumed. You have to use this one to figure out your nominal here. So we go 15 plus 12 divided by 2. So you're saying that it's halfway between these two guys. Okay? So it's 27 divided by 2. That is 13.5. Oops, you can't see that, can you? There. It's 13.5. Okay? So I want you to add this to your study sheet. If you have this on your study sheet, you can honestly ace these types of questions. But if you don't have it, you're probably going to struggle, right? That's the only homework piece, all right? See you tomorrow.